So I'm going to jump into section 5.6, and I need to do a lot of theory before we get into the sections, because the theory is way harder than the algebra. The algebra is simple, and it has to do, well, with the y values of points on the graph. And very specifically, every point that's on the x-axis, regardless of the value of x, has a y equal to 0. And in this section, we're kind of using function notation. So instead of saying y, we'll use some function name equal to 0. For instance, here's the point 8, 0. Here the x is positive, but the y is 0 because this point is on the x-axis. Here's the point 3, 0. Again, the x is positive, but the y is 0. Here's the point 0, 0. The x isn't positive nor negative, but the y is 0. Here's the point negative 5, 0. X is negative, but the y is 0. So irregardless of what the x is, any point on the x-axis is going to have a y equal to 0. That's a big deal. Similarly, every point above the x-axis, this is the region of the graph above the x-axis. The x-axis is there. This is above the x-axis. Every point above the x-axis has a y specifically greater than 0, or symbolically f of x is greater than 0 if I'm using the function notation instead of the y. For instance, here's the point, I think that's 6, 3. Here the x is positive, which doesn't really tell me whether the y is going to be positive or not, but the y is also positive. Here's the point 1, 2, 3, 4, 5, 2, 5. The x is positive and the y is positive. The x doesn't impact whether the y is going to be positive or negative. Here's the point 0, 2. Here the x isn't positive nor negative, but the y is positive. All of these points are above the x-axis. Similarly, maybe the point negative 3, 6. Even though the x is negative, the y is positive because the point's above the x-axis. Or maybe the point negative 7, 1. Doesn't matter whether the x is negative, positive, or 0. If a point is above the x-axis, the y's are greater than 0. The f of x is greater than 0. And lastly, every point below the x-axis has y's that are less than 0, or f of x is less than 0. For instance, here's the point 6, 2. I look at the x, it's positive. It doesn't impact whether the y is positive or negative or 0. Here the y is less than 0 because it's negative. Similarly, maybe the point 1, 4. Even though the x is positive, that doesn't impact whether the y is positive or negative. Because these points that I'm plotting now are beneath the x-axis, their y's are guaranteed to be negative. I have no guarantee on the x's. The x's could be positive, the x's could be negative, but any point beneath the x-axis, it doesn't matter whether the x is positive, whether the x is 0, or whether the x is negative. Any point beneath the x-axis, if I look at their y's are all going to be, this is probably negative 3 here. Their y's are all going to be negative. 1, 2, 3, 4, 5. This is a big deal in this section to understand that it doesn't matter what the x's are. If points are above the x-axis, not on the x-axis, but above the x-axis, that the y's are greater than 0. if points are beneath the x-axis, doesn't matter what the x's are, their y's are less than 0. And if a point's spot on, right on top of the x-axis, on the x-axis, the y's are equal to 0, or in function notation, the f of x's are equal to 0. That's a huge, huge important thing to understand, because all of the questions in this section are going to ask, where are the y's equal to 0, where are the y's greater than 0, or where are the y's less than 0. Let me do some stuff not in the section yet, because there's not enough problems in the section, and give you a feel for what the problems in the section are going to look like. So let me draw just a generic parabola. All the problems in the section are going to have parabolas. So -1, -2, -3, -4. Here's the point 6, -4. I'm going to make it the vertex of a parabola that has x-intercepts, or crosses the x-axis at the point 2, 0, and let me see, and the point 10, 0. I'm going to just draw a nice big parabola here. We're going to need to separate the graph into regions. The regions to the left of the x-intercept, the region between the x-intercepts, and the region to the right of the x-intercept. So I'm going to describe the region to the left of the x-intercept two different ways. One, without including the x-intercept, and with including the x-intercept. If I look at this graph, I'm going to break it up into three pieces. The piece to the left of the x-intercept, the first x-intercept, and that is the x-intercept of 2, 0. And I'm going to describe this region in terms of x's. This region, I'm going to say it goes from the far left edge of the x-axis, which has an x-coordinate of -infinity, up to the x-intercept of 2. If I want to describe this region of the graph, everything to the left of that dashed line that I drew, and I don't want to include the x-intercept, I say it goes from x equal to -infinity up to x equal to 2, and I'm not going to include the 2, so I'm going to round bracket it. Round brackets include everything up to the point, but don't include the point itself that's mentioned. So this includes something that's microscopically close to the point 2, 0, but not the point 2, 0 itself. If I wanted to describe this region to the left of the first x-intercept, and I wanted to include the x-intercept, I'd square bracket the x-intercept. The next region I want to describe, in terms of x's, is the region between the x-intercepts. I'm going to abbreviate intercepts because I'm out of room. And then first I want to do it without including the x-intercepts, and then with including the x-intercepts. And when I create these intervals, I'm doing them with x's and not y's. The first interval is going to go from the x-intercept at 2 to to the x-intercept at 10, round brackets exclude the x-intercepts, the points where the y is 0. If I want to describe the region between the x-intercepts, including the x-intercepts, I square bracket the 2 and I square bracket the 10. The last region that I want to describe is the region to the right of the x-intercept, the far right x-intercept. And I want to do it without including the x-intercepts, describe it one way, and describe it with including the x-intercepts. So this region is going to go from the x equal to 10 on the x-axis to the far right edge of the x-axis, which has an x-coordinate of infinity. So this region, if I'm not including the x-intercept, I'm going to say it goes from x equal to 10 to infinity. Round bracket includes the points that are microscopically close to the x-intercept but doesn't include the x-intercept. And if I want to include the x-intercept, I'm going to square bracket the x-intercept. So these are all the parts of the graph that I have to understand. And for each of the intervals, I have to say whether the y's are positive, strictly greater than 0, whether they're positive and possibly 0, whether they're negative, and negative and possibly 0. In this first top region right here, if I'm looking at this portion of the graph, the region that's to the left of the x-intercept, but not including the x-intercept, because all those points are above the x-axis. When points are above the x-axis, the y's are greater than 0. So in this first region that I've drawn, I'm going to say in this region, every single y is strictly positive, and I don't have any y's that are exactly 0 because I'm excluding the x-intercept. So in the region to the left of the x-intercept, not including the x-intercept, because the graph is above the x-axis and because points above the x-axis have positive y's, I'm going to say all the y's are greater than 0, or that if it's a function, the f of x is greater than 0. For the second region, I'm including all the points that are above the x-axis, and I'm including the 0. And in this region, I'm going to say all the y's are either positive, they're the points above the x-axis, or they're the x-intercept and their y is equal to 0. So in that region, I would say the y's are greater than or equal to 0. The reason this is because the portion of the graph that corresponds to this interval is above the x-axis, and above the x-axis, y's are positive. When I look at the two regions between the x-axis, the regions between the x-axis, if I'm not including the x-intercept, corresponds to this portion of the graph, the regions between the x-intercepts, and that whole portion of the graph is beneath the x-axis, and portions of the graph, when points are beneath the x-axis, the y's are negative. So in this interval from 2 to 10, every single point along the graph, its y is specifically going to be negative. So I'm going to describe this region. I'm going to say this region, the region between 2 and 10, not including the x-intercept, that all its y's are negative. For this region, I'm adding the x-intercepts to this region. I'm taking the points between 2 and 10 where all the y's are negative and adding the x-intercepts where the y's are 0. For this region, I'd say the y's are either less than 0 or equal to 0. They're equal to 0 at the intercepts. They're less than 0 between the intercepts. The last regions correspond to this portion of the graph. In this portion of the graph is above the x-axis, And when a graph is above the x-axis, the y's are all greater than 0. So this interval 10 to infinity, the x's correspond to these y's, and these y's are all going to be bigger than 0 if I'm including everything but the x-intercept. The bottom version of this, it includes all the points where the y's are positive, along with this point where the y is equal to 0. In this bottom region, I would say the y's are either greater than 0, meaning they're up here, or they're equal to 0 because they have the x-intercept. This is going to be how we're going to have to interpret the graph. We're going to be given a graph of a parabola. We're going to need to create 6 separate intervals, and for each one of those intervals, we're going to have to decide if the y's are positive, negative, and positive or equal to 0 or negative or equal to 0. We need to do one of these graphs upside down, and I'll try to walk through the upside down explanation. It's exactly the same explanation, but everything gets reversed. So I'm going to make another graph of a parabola. I'm going to make the vertex at the point -3, +9. And I'm going to make it go through the point 0, 0, and the point -6, 0. Like a nice narrow parabola that looks like this. So I have the point -6, 0 for one of my x-intercepts, 0, 0 for another one of my x-intercepts. I want to describe the 3 regions of the graph. The first region of the graph I'm going to describe is this region to the left of all the x-intercepts. And I want to do it without including the x-intercept, and with including the x-intercept. When I create the intervals, they're in terms of x's. This interval, the first interval, is going to go from the far left edge of the x-axis, which is -infinity, up to the x-coordinate of the x-intercept without including the x-intercept. That's going to be double round parentheses. Infinities always get round parentheses. Points on the graph get round parentheses if they're not included. This bottom interval is going to be the same, but I'm going to include the x-intercept. Next, I'm going to describe the region between the x-intercepts. And I'm going to do without including the x-intercept, and with including the x-intercept. That's including the point that has a y of 0. The without is just going to go from -6, the first x-intercept, to 0, the second x-intercept. I'm not including them, so I round bracket the x-intercepts. The middle, including the x-intercepts, I just square bracket. And then my region to the right of the x-intercepts, it's either without including the x-intercepts or with including the x-intercepts, would go from the x-coordinate of 0 to the far right edge of the x-axis, which has an x-coordinate of infinity. If I'm not including the x-intercepts, everything's round bracketed. If I am including the x-intercepts are square bracketed. Now I'm going to describe the y's. In these first 2 intervals, the graph is beneath the x-axis. So in this first interval, the y's are going to be negative because the graph is beneath the x-axis. So for this first interval, I'm going to say the y's are strictly less than 0 because I'm not including the x-intercept that has a y of 0. For the bottom version of this, if I'm including the x-intercept, I'm going to say the y's are certainly negative because the graph is beneath the x-axis, but because I'm including the x-intercept, they're either negative or they equal 0 if it happens to be the intercept itself. The middle interval, because in the middle interval the graph is above the x-axis, and any point above the x-axis has positive y's, in the middle interval, if I'm not including the x-axis, I'm saying all the y's are greater than 0 because they're positive. In the bottom version of this, same interval but including the x-intercepts, I'm saying the y's are either positive or equal to 0. So they're either greater than 0 or equal to 0. The last region, because the graph in the last region is beneath the x-axis, all the y's are negative. In this version of that, the y's are less than 0. Almost out of time, so I'm going to do this quickly. And in this region, the y's are either less than 0 or they're the x-intercept and they're equal to 0. This is how I'm going to need to dissect the graphs when I go to do the homework to answer the questions. I'm going to pause now and actually do the homework with you guys.